This conference will now be recorded.
Any questions from the Docker? Okay, fine. Now, after the completion of Docker, I hope you understand Docker is an engine. Docker is an container engine which will run the multiple containers, multi-container, or also in the Docker Swarm we can run the multiple containers, or else in a Docker engine we can run the multiple containers for multiple applications on different port numbers that we have seen in the Docker configuration. So today what we have to discuss, so the entire thing, what is the basic concept that we should rely is on the Docker only. So on the engine only all the containers will be running. That is the main point which you need to understand. So the next thing what we have to discuss here is, well, coming back to the next point. So after Docker we have some limitations with the Docker Swarm whenever we are working with the Docker Swarm. So Docker we can install on a single server, and if at all if we are running on a single server, then that will be a single point of failure. So to overcome this problem, what I am doing, I am going for the Docker Swarm. On Docker Swarm, I can create multiple multi-master, multi-node clusters, so that what happens if one node is down, still we can have the communication, or else still we can have the application access from the another node. So this is what we know. But when you coming back to the next concept, our Kubernetes, the next thing what we have to discuss here is Kubernetes, which will be having a wide variety of opportunities, and there won't be any limitations like Docker Swarm. So Kubernetes is primarily worked, or else we will be working with Kubernetes in production grade. Okay. So majority number of companies may be using, if at all, if they ask you to learn Kubernetes, so definitely they will be implementing the Kubernetes on their production grade. So how we can create the cluster, and how we have to deploy the cluster, and what are the components that are available on the Kubernetes. So first and foremost thing that you need to understand, what is this Kubernetes? Okay, or else everybody will say it as K8s. What is this K8s? So actually this Kubernetes is derived from a Greek word. Okay, Kubernetes is nothing but a sailor or else a pilot. In general, Kubernetes refers to the drive, or else a person who is running the ship. Okay, so or else the ship that is carrying out or else managing some of the containers will comes under the Kubernetes. But anyways, here the Kubernetes comes under, it's a management service, it's an orchestration tool. Okay, what is this K8s again? K8s means between K and S there are eight letters, so that will comes under K8s. Okay, fine. Now when we coming back to the next one, what is the main functionality of this Kubernetes? Like Docker Swarm, Kubernetes is also a orchestration tool. Orchestration tool. So what is this orchestration? What it is going to do means the Kubernetes is also going to manage the nodes, whatever the worker nodes. So here it just acts as a manager. It won't do anything. If you see the architecture of your Kubernetes, like how it is going to be, there will be two different types of planes. One will be the control plane, and the other one will be the data plane. One will be the control plane and other will be the data plane. So in control plane, what you will be having here is all the master servers will be deployed on the control plane. On control plane. So all the master servers will be deployed on the control plane, and all the worker nodes will be working on the data plane. Okay. So whatever the applications that are working, whatever the applications that are handling by the Kubernetes, those applications or else those application containers will not be available on the control plane. Every application related containers will be available on the data plane. So inside this data plane, what we are going to have here is we will be having node 1. You can implement multiple nodes also. Multiple nodes are nothing but your servers. Okay, don't get confused again. So node 1, node 2, and node 3. Like in Docker, we will be having multiple nodes. So this is about your data plane. Inside the data plane, what we will be having the basic components of the Kubernetes, that is called as a pod. Okay, so try to understand here. We are getting a new terms here. So the first term that you have to understand here is the terminology of Kubernetes. The first term is pod. What is this pod? So we will come to know about the pod and what is the main functionality of the pod in later on sessions. But as of now, try to understand pod is also like a container. I'm saying it is like a container, but I am not saying that it's a container. Okay, so inside this data plane, you will have the pods. Okay, like this. So multiple pods will be available on my multiple servers or multiple nodes. How we are going to manage the pods, that you will understand whenever we are going in deep into the content. Now this is what I can call it as, it is called as worker, okay, worker node. I can make it as worker node. So these are all worker nodes which you are having, and later on what we can do here is we need to discuss about the master. Actually the point here is, here we will be having the master nodes. So these master nodes are responsible for managing your entire cluster. So whatever the worker nodes that you are seeing, all the worker nodes will not be managed by themselves. So on the next point, what you need to understand here is, on each and every server, either it might be a master server or else it might be a worker server. In any server, we need to install the container engine. So either it might be a Docker engine or container D, any type of engine. First of all, we need to install in all the nodes. I'm not talking about only workers. I'm talking about the masters and workers. In all the nodes, we need to implement the what I can say, Docker or else any container engine, container D, RKT, container IO. Like that, we will be having multiple types of container engines. Among those container engines, whatever preferable for you, you can install them. But we will be working with the Docker containers, I mean Docker engine only. And the next point here is, when we coming back to the control plane. So in this control plane, it is not going to do anything related to your application. Okay, anything related to your application, in the sense, here the control plane will manage us this entire data plane. So whatever the control plane servers are there, if at all, if we will be calling them as master servers, all these master servers will be managing the servers in the data plane. So when you go for the control plane, we can have multiple master servers, so they will be following the raft algorithm only. When we go back to the Docker, in Docker, whenever we are using the Docker Swarm, there I have discussed about the raft algorithm, saying that so the Docker Swarm cluster will be working with the raft algorithm, so that number of masters should be in the odd number, and n minus 1 by 2 will be the quorum. So this is all the things that we have learned. So fault tolerance and highly availability, we will be following a formula called as n minus 1 by 2 nodes. So which means that if there is a 5 node cluster is there, then definitely how many nodes should be running? 3 nodes should be continuously running. 2 nodes, up to 2 nodes. If 2 nodes are failed in a 5 node cluster, if 2 nodes are failed, then there won't be any problem. But if 3 nodes are failed, then the cluster will be failed. That is how the raft algorithm and leadership, and then candidates, candidate elections, and all the concepts we have understood. So in the Kubernetes also, if at all, if you are having multiple masters, multi-master servers. So this is master 1, and then what I can do, master 1, master 2, and master 3. So what will be there inside these masters, I will tell you. So this is master 1, master 2. These are all the master servers which we are deploying in our control plane. So master 2 and master 3. So whenever we are discussing about these master servers, what happens here? So these master servers will manage the worker nodes. So multi-master, why we need a multi-master? Why can't we manage with the single master? Of course, you can manage with the single master, but the point is here, if there is any failure, if there is any point of failure, if one master is down, then still the cluster has to run. So that is the reason we need to configure multi-master. So whenever we are configuring this master servers, what will be there inside the master? So you are saying that these master servers will manage the entire cluster. So what are the available components inside the master servers? So if you create n number of master servers also, there will be the same components. There are five major components of your control plane. There are five major components in the Kubernetes for managing the entire cluster, and we will discuss about those five major components. But as of now, did you understand what will be there inside a Kubernetes cluster? So how many types of planes will be there, and what are the main functionalities of the planes? Okay, so when we go back to the next one, here, whenever we are working with this master servers, what will be there inside a master? This is very, very, very important. So without this knowledge, we cannot go further. Let me show you what will be there inside a master server. So this particular components, whatever the components that I am discussing right away, all these components will be available on all the Kubernetes cluster. So the first point here is inside a master server, inside a master server, what are the multiple components? The first one is API server. So application programming interface or else. So API server will be available. What is the main functionality of this API server or else Kubernetes Kube API? We will call it as a Kube API or else API server. So I will make this as a main important one. So whatever the commands that we are providing whenever the Kubernetes, so how we will be interacting with this Kubernetes cluster, the interaction with the Kubernetes cluster will be happen. The interaction with the Kubernetes cluster will be happen through a command line. So that is called as kubectl. So whenever we are working with AWS CLI, then we will be giving AWS. In the same manner, kubectl is also a command line tool which will be helpful for communicating with the Kubernetes cluster. So to communicate with Kubernetes cluster, we need to use a command that is kubectl. So we will be installing that also. Whenever the user runs any command, kubectl and run pod, if I give like this, then this command will be communicating with the API server. It will be directly transmitted to this API server. Now, this API server, what is the main functionality of the API server? The API server will interact with the data plane and try to start the pods. How it is going to start the pods, you will understand now. Let me do one thing. I will go back to my diagram over here. Let me remove these master servers and I will explain you the point here only. Okay. So if you see here what is the first component we have? API server. Now this API server is the heart of your entire Kubernetes cluster. If the API server is down, then the entire Kubernetes cluster is down. Okay. What is the point that you need to understand here is if you are having a single master and that API server is down, the entire cluster is down. If at all if you are having the multi master, these components will be synchronized with all the another master servers also, then you don't need to worry about that. But as of now, this is the main and most important components which will be working in the Kubernetes to manage the nodes and to manage to control the every controller or also every pod that we are deploying, every service that is available on the master servers. All these services has to communicate with the API server only. And the next one here is, here you are having one more component that is called as HCD. We will call it as HCD. What is this HCD? HCD is a data storage. In the other terms, everyone will say that it's a database, but I will tell it in a manner like that. HCD is a data store. Okay, so data store in the sense where it is going to store the data in the key value pair. So which data will be available inside the HCD? So related to your cluster environment, whatever the data that is related to your cluster environment, like, so if at all if I have to say how many nodes are deployed, nodes colon 3. So this is the key. Node is key, and value is 3. Okay, and the next one is how many pods are deployed. Pods equal to somewhere like 3. So like this, related to your entire Kubernetes cluster, whatever the data that is related to your Kubernetes cluster, the entire data will be available inside the HCD. Now, how this HCD will get this data? So to get the data by the HCD, what happens in the backend is this HCD, or else the API server will communicate with the HCD, saying that whenever it creates an app, or else whenever it creates a pod, so automatically the data will be transmitted to the HCD by the API server. So API server will says that we have created these many number of pods that belongs to this particular application. So store in your uh, save this values in your store. So what HCD will do, HCD will store that values. And the next one here is, here we are having a top notch one that is very important, that is kube scheduler. What is the main functionality of this kube scheduler? It is also a primary component and a very important component. It is like a headache for API server. Okay, kube scheduler. Why it is called as headache? Because whenever this kube scheduler, every minute by minute, second by second, it will transmit, it will continuously communicates with the API server. Why it is going to communicate with API server? The point is the cube scheduler will continuously communicate with the API server and continuously ask for, is there any pod that I have to create in the data plane? So is there any pod that I have to create in the data plane? So the kube scheduler will continuously monitor the data plane nodes. How many nodes are there? Among the nodes, how many nodes are having the appropriate memory, and how many nodes are running how many pods, like how many containers, and inside that how much memory is there, how much CPU is there, and is there any efficient node that to run the pod. So these are all the criteria that it is going to look. So first of all, what it is going to do, every minute by minute, second by second, it is going to communicate with the API server. Why? Because the user will directly communicate with the API server for creating any type of containers or pods. So these pods are created by the user request only, right? So who will create these pods? Obviously, these pods, we know that the pods are created by the API server. No, actually the pods are created by the another environment, but the user has to communicate with the API server, and the API server later on communicates with its correlated pods, or else correlated services like kube scheduler, and later on we will discuss about a very important service also. But as of now, so this kube scheduler will continuously communicate with the API server asking for, is there any pod that I have to create, is there any new requirement from the user. So whenever it is continuously communicating with the API server, it is like if you see some movies of Kamal Hassan, or else so he required a job. When he required a job, he will continuously follow up with the person wherever he goes. Our network follows in this manner. So the person will continuously follow the person who said that I will provide you the job. So in the same manner here also, the kube scheduler will continuously follow up with the API server. Is there any pod I have to create? Do I have any request from the user? So do I need to create any pod? So whenever it is communicating with the API server, the API server will say that no, you don't need to create any pods or else any deployments. Right now we don't have any requirements from the user. So whenever the user gives the requirement, then what kube scheduler will do, kube scheduler will analyze the data plane, how many servers are there, and what is the memory resources, what is the CPU utilization, how which server is very good for creating this pod. Depending upon all these things, this kube scheduler will schedule the pod deployment. Okay, among these three servers, this particular server is very helpful for creating the pod, very useful for creating the pod. So I can create the pod on this server depending upon the memory utilization, or else whatever the specs that it is going to go through, all the specs it is going to check out, and it is going to give a best node, best server to create the pod. And just it is going to schedule that, that's it, and it is not going to deploy the pods. Now who will deploy the pods, who will fetch out the container images, who will do all these things. So there is a concept, or else there is a service called as, hold on, kubelet. This is very very important service, where this kubelet will be available on all the nodes, whatever the nodes that you are seeing, whatever the data plane nodes that you are seeing, on all the data plane nodes you will have this kubelet. So without kubelet no node will be configured. That much important component it is. So who will deploy the pods, who will maintain the pods, who will maintain the containers, all these can be done with the help of kubelet only. So this kubelet will be available on all the worker nodes, and as well as it can be available on the API server also. So this kubelet, what is going to happen, whenever the kube scheduler schedules the task, this kubelet will create the nodes, create the pods or containers. So it is going to check out, okay, the user is requesting the requesting to create a pod, I will create the pod. Inside the pod you will have the containers. Right now you try to understand pod is like a container only, but it is not a container. So inside a pod we will have multiple containers. So you will come to understand about the pod in the basic components, primary components of the Kubernetes. But as of now we are trying to create the Kubernetes cluster. Once cluster is created, then we can create the pods. Now what kubelet is going to do, kubelet will search for the kubelet will search for the images, and it is going to create the pods. So if at all if we want to delete the pods also, this kubelet will delete the pods. So the most important component of your data plane for creating the pod and for deleting the pod is kubelet. So if at all if anybody asks you in the interview what is the main functionality of the kube scheduler, what is the main functionality of the kubelet, here you can see, if you go down, so the main functionality of the kube scheduler is is responsible for scheduling the pods to run on the node inside the cluster. When a new pod is created in Kubernetes, the kube scheduler is responsible for selecting the suitable node. It is responsible for selecting the suitable node only. It is not going to create the pod or to run on the pod based various factors. What are the factors? So you will learn about this resource availability, node affinity, anti affinity. These are all the things that you will learn in the advanced scheduling. We are having a separate class for advanced scheduling, Kubernetes advanced scheduling. There you will learn about this node affinity, pod affinity, and all the things. So kube scheduler performs its scheduling function by periodically querying the kube API server. I said you this one. So every time, every minute by minute, second by second, it is going to ask the kube API server, do we have any new pods to deploy? So how it is going to create, kube scheduler takes into account various factors when selecting a node for a pod, such as the amount of CPU memory resources available on each node, the node's geographical location, pod affinity, anti-affinity requirements, and other constants specified in the pod configuration. It is also it also considers the factors such as node taints and tolerations. This you will learn in the scheduling, taints and toleration, pod affinity, anti-affinity, all these concepts you will learn in the advanced scheduling concept. So don't worry about that. So once the kube scheduler, so the primary thing what you have to understand here is kube scheduler is for scheduling the pods. That's it. And when we coming back to the next one, here you will have an kubelet. Kubelet is a component of Kubernetes that runs on each node. This is very important. Each node in the cluster. Each node means either it will be a master node or else it will be a worker node. In every node you will have this kubelet in the cluster, and is responsible for managing the state of node and ensuring the containers are running as expected. When a pod is scheduled to run on a node, if at all if we want to if at all if we if the kube scheduler is scheduled a pod to run on a node, then kubelet is responsible for ensuring the necessary containers are running. Who will run the containers? So scheduler work is to schedule the pods. Now who will run the pods, who will maintain the containers inside the pods, the total responsibility will be taken by the kubelet, and that they remain running throughout the lifetime of pod. It does by this by communicating with the container runtime. So kubelet will, as I said you that, so containers are created on the container engines like Docker and all the things. So kubelet will communicate with the Docker and try to run the containers. Okay. Next one, in addition to manage the containers, kubelet also performs other important tasks such as nodes on the node, such as monitoring the node health, mounting and managing the volumes, managing the container logs, handling the pod lifecycle event. These are all the things that will comes under the kubelet working. Okay, the main functionality of the kubelet. And the next one here is kube controller. Kube controller, in the sense there will be controller manager inside your master server. So this controller manager is also communicating with your API server only. So all the components of your master nodes will be interacting with your API server, which you need to remember. This is very, very important point which you have to remember. So whatever the nodes, either it might be kube scheduler, kube controller manager, HCD, everything will be communicating with the API server only. So without API server, any another services will not be working. So this is my kube controller, or else kube manager, management controller manager. I can say it as kube controller manager. Okay. So it is also, what is its functionality? If you see here, the functionality of kube controller manager is a components of the Kubernetes that runs on the master nodes and responsible for managing various controllers that oversee the different aspects of your cluster. So node controller, so what it is going to do, the kube controller is going to create the node controller. It is going to monitor the health of each and every node. So if one node is down, so then what it is going to be, it is going to take an action. So it is going to say that the node is down. If at all, if possible, it is going to create another node like that. Not creation, but yes, it is going to say that this particular node is down. And the next one is replication controller. You will understand what is this replication. This controller ensures the specific number of replica of the pods are running on at any given time. So you will have a concept of primary components of Kubernetes. These are the prime Kubernetes cluster, and there is another concept called as primary components. There we are having a topic called as pods, replica sets, and then deployments, stateful sets. All these component concepts you will learn in this, but on that particular topic whenever we are discussing about the primary components. But as of now, so your Kubernetes controller manager, whatever the service you are having, this service is mainly responsible for node control, replication control, endpoint service controls, and like everything is managed, everything is controlled by your Kubernetes controller manager. How it is going to do that? So this can be done by communicating with the API server. Without communicating with the
ఇప్పుడు
API
దాకా
server,
ఏం మాట్లాడలేదు ఇంకా ఆ రోజు మాట్లాడే పథకాలు అప్పటి నుంచి టార్గెట్ చేస్తాడు అవి.
so whatever we are discussing, that that can be managed by your kube controller manager. So these are the four important components of your master nodes. So among that, there is another component is also available, that is called as Cube Cloud Manager. If there are any cloud services that are available, like your EKS and all the things, those can be managed by your Cube Cloud Manager. But as of now, that is not that much important, as we are creating the cluster. So for managing the cluster, these four components are very, very important. Among this, kubelet is also important. And one more thing here is, as I am saying you that this Kubernetes servers, whatever the nodes are there, all the nodes, we will have the pods. Now, who will manage the network of this entire cluster? For managing the entire network, we are having a concept called as kube proxy. This is also very important component. The name is kube proxy. So kube proxy is the main component to assign the IP addresses. So proxy is the main component to assign the IP addresses for your for your pods, and for the containers, in not the containers, for the pods that we are running. So, and to make the pods, for making the pods communicating with one pod to the another pod, proxy is very, very important. So it is like a networking component which you need to understand. That's it. So these are the components of your Kubernetes. Understood? Any questions? Questions, guys? Understood the entire Kubernetes cluster? What are the, so, and one more thing that you need to understand here is, all these services will be available on the each and every master server. If at all, if you are going for the multiple master servers, in multi-master server also, when you take 3 servers, on the 3 servers you will have the these 4 components. That is API server, master one, you will have the API server. and then you will have the HCD, and you will have the Cube Scheduler, and then you will have the Cube Controller Manager. All these four, and if at all, if I have to go for the fifth one, Cube Cloud Manager is also available on all the on all the nodes. This is on the master one. On master 2 also you will have the same to same components. On master 3 you will have the same to same components. So whenever we are having all these components like this, then what happens, everything will be synchronized between the master servers. If one master server is down, still due to this components which are running on the another master servers, the cluster can continually run. So this is the main important point that you need to understand. Got the point here? Questions? Any questions, guys? Yeah. So cluster means it is always both master and worker working together. Okay. Any another questions? Any questions that you want to ask me? Understood this architecture? This is very, very important for you. Okay. So I don't know how many people are there. Anyways, coming back to the next one. So right now let us create the cluster. So here we are having multiple ways of creating the cluster, not a single way. We are having KubeAdmin. There is a tool called as KubeAdmin, and there is a tool called as what I can say here is COPS. Using COPS, Kubernetes operations. So with the help of COPS, we can create the cluster. And then with the help of a Rancher, there is an option called as Rancher for creating the cluster on on-premises environment. We are having a cluster management tool called as Rancher, K3s. Like that, we are having so many different types of tools for creating the cluster. But as of now, today we will be creating a Kubernetes cluster with the help of KubeAdmin tool. So to manage that, we are going to create with the KubeAdmin tool. So the first point that you need to understand here is, so as you can go with the configuration. Okay, so what we are doing here is create a single node single master multi-node cluster with the cube admin. We are going to create with the cube admin. How we are going to create this? So multi-node, single master multi-node means I am going to take one master server and three worker nodes. Okay, one master and three worker nodes. Let us see how we can create the cluster. So let me go log into my AWS console.
Then we have to install the Kubernetes at our the Linux server, right?
Yes. Let us see what we can do here. So this is my COPS management server, Kubernetes management server. Right now, I don't want to run it. Let me do one thing. Okay, done. So this is the different account which I am using for Kubernetes. So I'm going to launch 4 nodes. If at all, if you want 3 nodes also, single master, 2 nodes, you can go with that also. But I'm going with the 4 nodes. So what I can do here is, let me deploy the machines. Okay, so this is my k8s-master. Simply I can make like this. Okay, so the next one is on the Ubuntu machine. You can go with the 2004. Okay, so let me go with the 2004, and the next 22 micro is good, and AWS common key pair. In any subnet you can create this master server. I will go with subnet 1. Select an existing security group. Then I can go for the implementation of I am going to provide some user data. The user data is shebang/bin/bash. So what is this user data? This user data will be running at the time of creating your server itself. Okay, shebang/bin/bash apt update-y, and I am going to install the Docker itself. curl-s capital L https://get.docker.com, and when I go for bash, it is going to install the services. Okay, launch the instance. Done. And the next point here is, I will go with the I'm going to create 3 servers at a time. How I am going to create here is, these are the worker nodes which I am going to create. Right now we have a master server. That's fine. So let me launch the or else I will go with the cloud shell. Okay, I will go with the cloud shell. Hmm. Hold on. Hmm. Okay. Bash launch.sh. So the 3 servers will be created. Okay, good. But the point here is the servers will be micro servers, T2 micro servers. I want T2 medium servers. So for running the Kubernetes, the specifications that you need to check out here is you cannot run the servers on the T2 micro. You have to go with the T2 medium only. So T2 medium are the feasible servers. Okay. So what I will do, obviously they are going to charge for you. So this entire practical will cost you around some 20 rupees per day. So when how many times you will do the practical depends on that. So I am not going with the T2 micro, I will go with the T2 medium. So I will stop on all the servers. Let me do one thing, let me change the names for them. So this is my K8s worker node, worker 1. Okay, and this is my K8s worker 2, and this is my K8s worker 3. Done. So we have the 3 worker nodes and 3 on the single master node. So let me go with the specifications, or else let me go with the diagram how I am going to do this. Here we are having a master node. Okay, which will control the entire worker nodes. So where we have installed the Docker also. Here we have in the inside the master node we install the Docker. Okay, that's good. So inside this, what we will be having, we are having an API server. API server which we need to install. As of now, we have a master, and then what we just install the workers. So right now we did not connect the worker nodes with the master. Let us see how we can connect that. But as of now, this is my worker node 1, worker node 2, and worker node 3. These are the 3 worker nodes, Kubernetes worker nodes that are deployed on your Kubernetes cluster. Okay, hold on. K8s hyphen worker hyphen 1 Kubernetes worker hyphen 2 Kubernetes worker hyphen 3. 3 worker nodes are available. Right now, we did not connect any master server. Let me do one thing. This is my Kubernetes master. Okay, let me take the access of this Kubernetes master. First of all, what I have to do here is I will stop all the servers. Why? Because to change the instance type to T2 medium. So at the time of installing the servers itself, you have to select the T2 medium. But unfortunately, by default, they have selected the T2 micro. Let me do one thing. I will change the node types from. Mhm.
Sorry. What is the difference between the server macro and the medium? Is that configuration type?
So T2 micro will have 1 CPU and 1 GB of RAM, which is not sufficient to run the Kubernetes cluster. So minimum you need to have 2 GB of RAM. Okay, so when you go for T2 medium, you will have 2 virtual CPUs and 4 GB of RAM will be there in the T2 medium, which will be happily running the cluster. Okay, to run the cluster, we need to have the requirements. Understood?
Yes.
So we can create 4 VMs in the virtual box, right?
If you
Can we
want,
do
you
that?
can do that.
Okay.
Okay, so if you want to do the cost reduction, you can go with the VMware installation or VirtualBox installation, and you can do that also. But I don't recommend you to do on this virtualized missions. Why? Because whenever you go with the configuration, you'll be working with the cloud environment. So that is the reason I am saying you on the cloud environment. T2 medium. So I'm going to deploy all the T2 medium servers. Don't frighten for the money. Okay, so don't think this is like we are wasting the money and all the things. You are utilizing for the thing that is like an investment, not like a what I can say. Hold on. T2 medium. See, if I have to say some 5 6 Kubernetes classes, try to understand how much money I have to invest on this. So why I'm doing this? Because oh come on, hold on, hold on. Hmm. I already said you at the starting of the batch itself, it will cost you around some 2 to 3,000 rupees for Kubernetes. Okay, so do the practicals on the Kubernetes. That will be helpful for you, and that is on the AWS. And again, if you want to do this on the virtualization missions, then it will be some tricky for you. And again, you have to install all the things. That will be something difficult. Anyways, that's all your wish, guys. If you want to work on your virtual missions, also you can do that. What is there? You can create multiple virtual missions, and you can run the kube-admin on that. That won't be any problematic situation for you. Anyways, so let us start all the servers. Now let me take the access of this master server. So first of all, what I will do here is I will go with the master server. So here we need to check whether the Docker is available or not. As I already said you, on each and every node you will have the Docker installed. So let us check it out. Hold on. Hmm. Let us see whether the Docker is available or not. Docker PS. Right now Docker is running. That's good. Now, now we need to install the configuration, whatever the configuration that is required to run the kube-admin. So let me modify this so that you can clearly understand this is a master server. Okay, that's good. So now, first of all, we need to, as you can see, we have updated everything. Let me update again, apt update -y, so that the next thing what I can do here is install Kubernetes cluster with the kube-admin. Install Kubernetes kube-admin, or else I will go with kube-admin on Ubuntu 20.04. Okay. So here you can see, before you begin a compatible Linux host, what are the pre-requirements? The Kubernetes project provides the generic instructions for Linux distribution on Debian and Red Hat. So what they are saying, 2 GB or more RAM permission is necessary. Any less will leave little room for your apps. Okay, so minimum 2 GB of RAM is necessary. That is the reason I'm going for 4 GB of RAM, that is for T2 medium. And two CPUs or more. So as I already said you, T2 medium will have two virtual CPUs. And swap should be disabled. What is the swap? You will have the swap memory. You must disable the swap in order for the Kubernetes to work, kubelet to work properly. Okay, so we have to turn off the swap. And then what we are going to do here is we are going to install the container runtime. As you know that the container runtime is installed, that is Docker is installed, so we don't need to worry about that. And now we need to install the kubeadmin, kubelet, and kubectl. Kubectl is a component, it's a CLI. So what is kubectl? The command line utility to talk to your cluster. If the administrator wants to communicate with the cluster to deploy any pods, then he can deploy with the kubectl only. Now let us go for the installing the Kubernetes kubeadmin. Here you can see apt sudo apt get update apt install -y, transport HTTPS, CS certificates, and curl. These are all the things that you need to install. And then I have merged these two commands and made a single command, single and simple command over here. Let me show you that one. So here you can see curl hyphen s. This is for the Ubuntu servers which are the previous generation, like 2004 versions. And for the latest servers, that is whatever the servers that are running with Ubuntu after 2021.0 and 22, these servers must be running with this particular command. So anyways, this is what the command that we have to run. Okay. And for what? For downloading the Kubernetes public sign key, Google Cloud public sign key, and Kubernetes apt repository. So to download, to add the Kubernetes repository, we need to run those commands. Okay. And the next one here is what we are going to do. We are installing the kubelet, kubeadmin, and kubectl. So if you give like this, whatever the latest version is there, so sudo apt get install -y kubelet, kubeadmin, kubectl, it is going to install the latest version. If you want to install the version that you require, you have to specify that version number. Here you can see that. See here, sudo apt get install -y kubelet equal to 1.26.1. So which means I have provided the version. So now let us go back and create this. First one, what I want to do here is, as already Docker is installed, sudo apt get update, and I want to install all these things. I want to run these commands. Let me run these two commands first on my master node. Okay. And then what I want to do here is, again, I want to run this command curl -s. Let me copy this. Okay. Hold on, there is a problem here. I have a separate file for this. Let me check out this. Installing kubeadmin, this good. So what I can do, I can same commands, what are the commands that you have seen there, the same commands I am providing here also. Okay, done. So on the next one here is what I can do. After doing so, I want to install this swap off. Let me run this as swap off, so that the swap memory will be off, so that Kubernetes, whatever the kubelet is there, kubelet will work fine. For that, I'm doing this swap off. And the next one, what I can do here is, I want to run this kube apt update, and finally we want to install the kubelet and kubeadmin and kubectl. Okay, hold on. So here there is a problem. What is this? By default in Linux, you will have the containerd application running, and we have installed the Docker. So I want to make sure that Docker should be working as a default containerization engine. So to do so, what I have to do here is, here there is an option. First of all, let me sudo apt mark hold kubelet, kubeadmin, and kubectl. So do you know what is the meaning of this hold in Linux? What it is going to do? Apt mark hold, what it is going to do? Any answers? Okay, so in Linux, hold in the sense, what is happening here, we have installed a version called as 1.26 for kubeadmin 1.26, kubelet 1.26, and kubectl 1.26. Right now, Kubernetes cluster or else kubectl is of 1.27. Okay, somewhere like the version is upgraded. So whenever the version is upgraded, for example, if I go for apt update again, if I run the command apt update again, automatically all these applications, whatever the kubelet, kubeadmin, and kubectl, will be updated to latest version. So I don't want that to be happen. For that reason, what I am doing here is, I want to make them hold. I want to make them hold in the sense, I want to make them on the current version only. So for that reason, I am going for apt hold. And next, what I can do after creating this, I am going to initiate the network. So right now, what we have done here is, we have just created a cluster. So, but this cluster internally there will be a separate network for this cluster. Whatever you see external communication, that is different, and for the internal communication, for the pod communication, you will have a different network you need to configure internally. But the point is this cannot be done. If I give this command, let me show you. If I run this command, it is going to throw an error. So what is the error? So it is saying that okay, what you said is you have to use Kubernetes version 1.26. I will use that. But what I am doing, I am trying to run, but what is happening here, container runtime is not running. So output time and level fatal and message validate service connection CRI v1 runtime API is not implemented for the endpoint. So here it is running container D. Actually in the back end, don't we have the container runtime? So whether the container runtime is running or not on the back end. What is this container runtime? Anybody?
Since it is running,
I am not asking that. What is this container runtime? Yeah, exactly. Docker. In the back end, Docker is running, but it is saying container runtime is not running. Why? Because container D, it is trying to communicate with the container D. So what I have to do here is rm-rf. There is a file in etcd slash etcd container D container config.toml. This file I have to delete. So this configuration file related to this container D. So when I delete this and reboot the server once, let me reboot that. Once the server is rebooted, let the server will reboot. So now what I want to do here is I want to run all these commands. What are the commands that you are seeing here? I want to install all these commands on the worker nodes also. Now what I will do, let me take the access of the worker nodes, or else in the another way also you can do that simplification. So how you can do that? With the help of what I can say SSM manager also you can do that. But as of now I don't want that. Let me do one thing. I will take the access of the worker nodes one by one. Okay, new session. So su hyphen, and let me check whether Docker is available or not. Docker, yes, yeah, Docker is available. Good. Now what we can do here is let me run all these commands. Okay, hold on. Done. After that, we need to run this command swap off, and then we need to install the kubelet. Right now, I don't want to hold it. Let me do one thing. I will copy all these things. Okay, done. It is installing the Kubernetes kubelet. So sir, kubeadmin is only on the master. Why we are so again, why I have to remove that? Let it install on the worker, but worker nodes are not mandatory for like behaving like a master. So let it come, and later on, so here we have installed the required things, and now what I'm going to do, I'm going to hold it for updation. So no application should be updated. For that I'm making it as hold. Done. After that, here also we need to remove the container D file. Let me remove them. Okay. After removing this, I will reboot the server. Done. So worker node, whatever the required content is there, that I have installed, and after that I want to run on the worker 2 also. So you don't need to run on 3 workers. So if at all if you have 2 workers, that's more than enough. Try to install 2 workers only. We don't need to run 3 workers. So new session, Ubuntu, same configuration that we have to provide here. Okay, so again updation, done. And after that, what we are going to do the swap off, install the Kubernetes cluster. Okay, done. Whatever the required applications are there, we need to install that. Done. So after that, we need to remove the container D. Whatever the file is there, we need to remove that. Hold on. Okay, done. So let me hold this. Then remove the file. Done. And reboot the server. Good. If you want to access the same on the third server also, you have to do the same. So this is all the manual process which is going to take the time. But tomorrow, whatever the session that we are discussing, that is about the COPS, Kubernetes Operation Services, that will be very easy for you. You don't need to work with all the things. Simply you can run the Kubernetes cluster. Same configuration, guys. Done. And finally, we have to do the whole, and we need to remove the conf.toml file. Hold on. Done. And then let me hold it. And finally, we need to remove this conf.toml. Okay, this is good. And done. So let me reboot the server. Once the server is rebooted, and everything will be fine, and we don't require these worker nodes anymore. So we want only our master servers. So we have installed all the things. We want our master server only. Sudo su hyphen. And here what we can do here is, I want to install a network. First of all, I want to run the network in my master server. So what is doing, kubeadmin, you want to initialize a network for our entire containers. See, when you go back to the docker, there will be a docker network, and if you go for the docker swarm, two different networks will be created for making the communication between the containers. What are the two networks that are available whenever the docker swarm was initialized? When we initialize the Docker swarm, what are the two networks that are configured?
Overlaid.
Yeah, exactly. Overlay network. In the same manner, overlay and gateway network. In the same manner, here also, we are going to install a network for the cluster configuration, cluster communication, for the pod communication. For that, we are creating this network. If you want to change the CIDR also, you can change the CIDR. For what I am going to do, let me run this. Okay, now it is running. Previously it is not running, it is throwing an error, but now when we remove that conf.toml file, it is going to be run. So after running this, what we can do here is, so here we have provided the default IP address as 192.168.0.0, but you can change it to 10 or 172, any private IP address. But when you change that, you have to do something different. I will show you that one. Hold on. So it is done, guys. So here we have generated a worker token. You can see here. Then you can join the member. So we got a worker token, kubeadmin join. So this is going to add my workers to my Kubernetes cluster. So when you go for the Docker swarm, simply when we initialize the Docker swarm, what we have done, sorry, where is the worker token here? When we go for Kubernetes, So what we have done, cube init, Docker Swarm init, what it is happening, it is generating a worker token. In the same manner, here also, the Kubernetes is going to generate a worker token. Here we have got a worker token, so which will be helpful for us to join, to make, or else to join this worker nodes into my network, into my Kubernetes cluster network. But before that, what I have to do here is, see here, they have given a clear cut commands. What is that? To start using your cluster, you need to run the following as a regular user. If at all, if you are a normal user, you need to run this. Alternatively, if you are a root user, you can run this. So we can run this, or else my command is like the copy this for normal root user, also copy this entire three commands and run it over here. So that what happens here, it is creating a .cube directory. If you can see here, there you go, .cube directory is created, and then it is copying the entire configuration file into our cube. So this is very important, cd .cube, and if you can see here, we have a config file. So whatever the data that is available, so if you see here, cat config, so this configuration file is very important. If you have this configuration file, you can access your entire Kubernetes cluster from anywhere. If you have the config file, that's more than enough. Right now I am having the configuration file, so that I can access my Kubernetes cluster from anywhere. So that is what we can do. And now I want to add my nodes, whatever the worker nodes are there. I just want to add my worker nodes into my Kubernetes cluster. But before that, we have our cluster, but we don't have the network connectivity. For that, what you need to do here is, first of all, you need to run this particular command. We are creating some pods. Okay, that is Tigera operator.yaml. And one more thing is, this is called as Calico network. Let me show you this one. When we run this, it is going to create a network for our Kubernetes. Okay, and the next one here is, I am going to run one more command over here. Actually, whatever the command that we are running, this command will be, see here, directly I am applying this YAML file. This is a manifest file where we will have the nodes and pods are available inside this manifest file. But anyways, I just want to show you one thing. Let me do one thing. Install Calico. Here you can see mm, hmm, Calico on Kubernetes cluster. So if you can see here, we can download this particular file. Actually, what happens? So installing, there you go. Curl hyphen, so manifest file, you need to download this resource.yaml file. So what is this resource.yaml file? So actually, this resource.yaml file, so what I will do here is, first of all, I will download this and I will show you one thing so that you can get a clarity. So where is this one? Come on. Let me download this YAML file. So how can I download this? Wget. Okay, so if you can see, custom hyphen resource.yaml is available. Now what I can do, cat custom resource.yaml. If you see here, default network they have provided is 192.168.0.0. By defaultly, whatever the custom resource.yaml is there, the network cider is 192.168.0.0. And if you can see here, on which network we have initialized our cluster, see there, pod network, whatever the pods that are creating, the pods are creating on the IP address 192.168.0.0. So whatever the cider we have provided here, the same cider must be there in this custom resource.yaml. If at all, if the cider is different, if you are creating 192.168 over there, and if at all, if you have 10 series in this custom resource.yaml, then the network won't be formed. So you need to be very careful. If you give your own cider here, if you change the cider as 10.10.1.0.0, then automatically in the custom resource.yaml also you need to have 10.1.0.0/16. Then only you have to apply this. But without changing this cider block, if you apply the configuration will not be accepted. So what is the condition here? if you are having different CIDRs. But as of now, I'm having the same CIDR, that is 192.168.0.0 only. So I don't need to change anything. Simply what I can do here is I can apply the file. So what I can do, cube admin, cube adm, apply -f custom resource.yaml. If you apply that also, you don't have any problem. If you can see, what is the command? This is, it is saying that we need to apply this particular file, kubectl apply -f custom resource.yaml. The same we are doing here also. We don't want to go for anything different. Okay, so it is going to create the network. Done. So now, as you can see here, the master server is able to communicate with all your worker nodes. The master server is able to communicate with your worker nodes, and if at all, if you want to create that, once we join the workers into the cluster, then we can create the pods. Now, as you can see here, where is the token? I think I have generated the token. So this token I have to provide. Let us see. So I will go back to, let me restart this. And one more thing that I want to show you here is what I said. In the Kubernetes master server, you will have the multiple pods. So let me do one thing. kubectl get pods. If I say this, it is saying that you don't have any pods running on the default namespace. So what is this namespace? A namespace is like a virtual cluster. Okay, so what I can do here is kubectl get po-a. If I give this, then automatically it is going to show me all the pods that are created on all the nodes. Okay, so it is saying that here you are having, so I said you will be having API server. Here you can see Cube API server is available. On which node you are having Cube API server? That is available on 172.16.1.231, which is nothing but that belongs to my master node. And Cube controller is available, Cube proxy is available, Cube scheduler is available, HCD is available. So on all what I said you at the beginning, on all the master nodes you will have these four to five components are available. So as you can see here, on our master server we are having all the components available. So this is how. But when you go to the nodes, worker nodes, you don't find them. When you go to the worker nodes, you don't find them. Why? Because in worker nodes these will not be running. So first of all, we need to add the worker nodes into my cluster. So let us add them. Restart the session. So, and one more thing, what you need to understand, kubectl get nodes. What are the nodes that are available? Only one node is available in the entire cluster, that is control plane node. What is the node name? The node name is 172.16.1.231. Let me do one thing. I will make this node, I will run this command for each and every second. Port-n1 kubectl get nodes. If I run this command, so it is going to run for each and every minute, sorry, each and every second. So what I can do here is I am going to add this worker node, sudo su hyphen let me add the worker node, copy this join token. Okay, and get over here. That's it. So here it is going to join the worker node also. It is running the pre-flight checks and waiting for the kubelet to perform the TLS bootstrap, and let it come. So on the another node also I am going to run this. Let me restart the session. I'll provide the value over here. It is going to work with that, and later on here also let me restart the session. Done. So I'm running the worker nodes over here. Here you can see the worker nodes are getting added. So look at that. So two worker nodes are available, and third worker node is also installing. Once it is installed, the third worker node is also available on your Kubernetes cluster. Hold on. That's it. That is how you can configure the Kubernetes cluster with the help of kubeadmin. So once we have deployed this, what we can do, so, and one more thing I want to run on this kubectl get to pods. If I run this on my worker node, kubectl get to pods, it is now, it is going to display that. So what it is saying, could not current API localhost. Okay, that's no problem. Now let me go back. One server is not getting ready, no issues. So let me do one thing, kubectl get nodes, we have the 3 nodes available, and kubectl get pods. By default namespace we don't have any pods, and let me run with or else let me run a pod, kubectl run test pod. I am trying to run a test pod on my servers. Okay, test pod. What I can do, hyphen image, through which image you want to run this test pod, that is Chaithanya Manikumar slash color game. If I run this version 1, it is going to pull out the image from the Docker Hub defaultly. See that kubectl get pods. If I run this command now, here you can see test pod 1 is created. Inside the test pod 1 there is a container which is running. Actually you cannot give in this manner, so the command should not be given in this manner. So if you want to check out on which node this particular pod is created, -o wide, if you give this, it is going to show you. Try to understand this point. See here, test pod is running and it is running on 172.16.2.172. This is the IP address of your node. 172.16.2.192 means which node it is? I think it's worker node 1. 172.16.2.192. On worker node 1, it is running the pod. And then here you can see the IP address of the pod. This is the IP address, as we have created a pod network. So as you can see here, we have given the command kubeadm init -pod network is 192.168.0.0. So the pods are running on the network 192.168.0.0. If you change the network IP, the pod network IP is going to be changed. The pod IP address is going to be changed. Here you are getting the pod on this particular IP address. So now the pod is running good. Now if you want to check out this kubectl get svc. So now the pod is running. If when it is running, it is no use. So the point is, whatever the application that is running on this particular pod, that should be displayed. How we can display that? If you can see here, kubectl get svc in the in the sense service. So I want to know what is the service. So right now Kubernetes cluster IP is there. So there is a separate topic for the services like cluster, and then we will be going with the node port. You will understand all these services: cluster IP, node port, load balancers, and then we will be having external IPs. Like that, we are having so many different concepts of svc, which we will be learning in the next upcoming sessions. But as of now, if you want to expose this particular pod, if you want to export the pod to the internet, how you can expose this? kubectl expose expose pod. What is a pod? Test pod 1 or else test pod port. On which port I want to run it is 8080 target port, target port is also somewhere like 80. So actually the application is running on port number 80 inside the container. And then type equal to, type is node port. What is this node port? You will learn in the next upcoming sessions. So here it is exposed. Now when you see here kubectl get svc, so here you are having this 8080 port number is mapped to 31970. This is then another port. So here you will get, definitely you will get the confusion, but this is the smoke test which we are doing right now. Try to follow this, and later on session I will explain you each and everything, why we are getting 31970, why it is mapping with that node port and SVC. We will be learning about all these concepts in the services section. Okay, so now what I will do, I will copy the, so on which node, or else on which worker node it is running, it is the pod is running on the worker node 1. So what I can do here is, I will copy this worker node 1 IP address. Let me paste it over here and provide the port number. What is the port number? 31970. Copy this and I paste it over here. You are getting the application, which means that when we communicate with this, so in worker node 1 we have a pod. So now the Kubernetes cluster will allow the external traffic to enter into this pod, and or else to enter into this node and to retrieve the data. Okay, that is good. And the next one here is this is how you can run the pod, and you can expose the pod to the internet. So not like this, actually you will be having different terms that you have to follow. And if you want to get the logs, so what I said, so let me do one thing, kubectl get nodes. If I go for this, we are having this 192.168. Let me do one thing, ctl describe node. I will give the node name. So this is the node name, or else I will go with the control plane first, which is a master node. I'll give like this. So, so come on. So what it is doing, try to understand. So what is this node? Here it is giving you very clearly. So it is a control plane node, which is a master node, and these are all the labels that are available. And the next one here is annotations, and what time it is created, and then you can see here what is the network status and all the things. You can go through this. And finally the main point here is, here you can easily see what is the CPU capacity, allocated CPU capacity, system information, and pod siders, everything is available. But this is not very important for you. The most important thing here is, this is the one. So what are the events that are running? So the events that are running here is kube proxy, which is for setting the network environment. And later on what it is happening, kubelet. So here kubelet work is nothing. So in the master servers we don't have any kubelet work, but when you go for the what I can say, worker nodes, there you can see the kubelet work. Let me do one thing, kubectl get nodes. Let me take the 190 172.16 2.192 to 192. If I give like this, here it is very important. See here, kube proxy, it is setting the network, and here you can see memory environment and node controller. Here you can see registered node. Now the node is registered and it is running the pod. So what it is going to do after that, it is going to schedule the pod creation also. Right now the pod creation should be shown. Why it is not showing? Let me do one thing, kube ctl logs. I want to get the logs related to what is the IP address, what is the network node IP. Host name is this one. Let me copy this. kubectl. I want to get the logs of the. Let me go with the kubectl logs pod test pod. If I give like this, also test pod, is going to show me the logs of your test pod. What are the test pod that are running? What are the services that are running? On which operating system it is running? So you can get the logs like this. And not only this, you can do one more smoke testing. Like if you go with this kubectl logs -f kube scheduler. So I want to know what kube scheduler is going to do. Actually, the IP address is 2.192, right? Or else 1.231. Let me do one thing. The master server IP is 1.231. So these are all the functions that the kube scheduler is doing. So if you want to get the logs, how you can get the logs is by going with the command that is kubectl logs -f kube scheduler. And if you want to get any another logs regarding your kube API server and everything, you can get the logs with this command. So this is how you can get the logs. And later on what I want to do, I want to give the labels. If you want to give the labels, you can give the labels also. So that totally depends upon your work. So how you are going to work with your pods and work with your environment. Right now, what is my intention here saying all this thing here is how to create the Kubernetes cluster with the kubeadmin. What we have done, we just ran some of the commands, and then we have added the worker nodes, and now we can run the pods. So what is this pod? A pod is a primary component of your Kubernetes cluster where all your containers are available. So you will come to know about this very in detail, but as of now, try to create the Kubernetes cluster with the help of kubeadmin. So I'm going to share you this document. Don't worry about this. I will share you the document. You can work with that. Okay. So that is about your kube schedule. Installing the Kubernetes cluster with the kubeadmin. Tomorrow we will see installing the Kubernetes with, cluster with the COPS, Kubernetes Operation Services. Okay. So that's all from my end. Any questions, guys?
Hello, sir.
Yes.
In this case, we just had one master, but let's say we need one more master. Then, or do we have the command to like add that as well?
Yes, we can have that also. The same, what you have to do here is you have to use the multiple master nodes and you have to run this. We don't, like in Docker Swarm, we don't have this Docker Swarm add managers. Okay, if you want to run the masters, you have to create another server, but that will be tricky for you. Okay, so which is a hectic task for you to create another master node. So first of all, whenever you are creating the masters with the help of kubeadmin itself, you have to understand how many master servers you want, and then you have to run it. Okay.
Okay.
Yeah, if you want, you can run that also. You don't need to worry about this. You are having a command to run that. Okay.
Same commands which we used in the master. The I will just replicate that in another one, right?
Yeah,
Okay.
fine then. Any further questions? Understood. And one more thing, as I already said you, one thing, the content is, if you are having this configuration file here, what I said, cd dot cube, and if you see here, here we are having config file. So let me do one thing, cat config. So I have this configuration file now, so that I can run, or else I can work with my Kubernetes cluster. Let me do one thing. I'll copy this config file. There is a software called as Lens. Okay, this install this Lens in your computer. That will be helpful for you. So there is a Lens for running this Kubernetes cluster, or else accessing this cluster. So let me do one thing. Hmm. So what I want to do here is I want to add a cluster. Just give the whatever the config file you are having, give this and add cluster. When you see here, Kubernetes admin, Kubernetes-admin, Kubernetes cluster is created. You have added into your Lens application, and then you can see how many number of nodes, how many number of pods that are running. So that kube config file is very important. If you have that one config file, you can access your servers, or else you can access your cluster from any of the configuration. So what is it is saying? Uh, okay, no worries. So we need to have the IP address. That's fine. Tomorrow I will show you on the COPS. Okay. So this is one of the concept that you can work with. I will show you that configuration in the next session of the COPS, so that you can clearly understand why. Because it is working on the private IP. Actually, here you can see server HTTPS 172.16.1.231.643 6443. 6443 is the default port number for your API server, but it is trying to communicate with the private IP. So if at all, if it is trying to communicate with the private IP, it is not going to happen. Or else what we can do here is, despite of private IP, I can give the public IP address of my server. What is the public IP of the master server? Okay, let me do one thing. I will try to access like this. Hold on. Actually, public IPs will not be exposed, but Hmm. Go to the lens, provide the IP address. The IP address of my server is, what is the public IP? This is the public IP of my master server. Let me provide it over here and add the cluster. Error while proxying the request, the certificate is valid for. Fine then. Actually, we can connect it, but as of now, it is on the public, it is on the private network, and the certificate is also generated for the private network. It is unable to connect. But tomorrow, when we discuss about the COPS, there I will tell you about how we can get the Kubernetes cluster. Okay, so that's about your kubeadmin, which is majority number of the way we don't use this, but anyways, you need to understand this point. So the companies will ask you to create the cluster with the cops, or else they will ask you to create with K3s or else rancher. So you need to focus on these three things, but kubeadmin is also one of the tool which will be helpful. But anyways, the final point what you need to understand here is how we can create the cluster with kubeadmin, and what I can say, what is the Kubernetes cluster, what are the primary components of the Kubernetes cluster. If you understand this, that's more than enough for me. Okay, questions? Fine then. Let me terminate the entire cluster. Santosh, is there any questions?
Uh, Actually, I do have a few of the questions. Okay, could you please share the architectural diagram which you are showing that?
Mm-hmm.
Okay, so here we architecture diagram, sir. In the paint you
Mm.
have drawn, right?
Yeah, the same you are having here. Yeah. Tell me. Actually, I have deleted this site, so that is not there. Yeah. Tell
Okay,
me.
so the
Mm-hmm.
so this cube scheduler. Okay, so it will connect. It will try to. So it will ask the API server whether do we need pods or not, right? And then
Mm-hmm.
if it is required, then it will check that which node we can create pods. Am I right?
Mm-hmm.
But the kubelet, the response, but kubelet is the responsible to create a pod, right? Not the kube scheduler.
Kube scheduler is responsible for scheduling the pods. Kubelet is responsible for running and starting the containers and pods. There
Okay,
is much difference between those two.
got it,
Okay,
got my. Okay.
if at all if you are in a college, okay, if your
Mm-hmm,
leader is saying that you have to do this work,
mm-hmm,
your faculty says that you have to do this work, okay,
mm-hmm.
and who has to do that work? Whether the faculty will do that, he will schedule that, that's it. And who is the
Yes.
person? You are the person who has to do that work. Okay, so here the cube scheduler is like a faculty and kubelet is like a student. Okay, cube scheduler will say that. So depending, so faculty will not select each and every student to do the work, right? So he will
Mm-hmm,
select the student who is or else he will select he will select the student who is okay with that work, who is intelligent to do that work. In the same manner, cube scheduler is also search all the nodes, among all the nodes which node is capable of running that particular
mm-hmm,
pod. That's it, it
mm-hmm.
is going to schedule that. And after that, who has to work with that? So inside that node, there will be kubelet which will be working on that. Okay.
Okay.
Yeah.
And what is the role of this etcd at code? What it does basically? Why do we need this?
So what I said about HCD,
I did not understand. That is what I'm asking again.
HCD is a data store. It is going to
Uh-huh.
store the entire data related to your cluster. How many pods, how many nodes, how many services, how many deployments are running. Okay. So if the so when the API server wants to know how many pods are running, to whom it will ask? It directly goes and asks the nodes. So the node will say that I am having only single pod. Actually, for services, for if at all if I am running an application, the application is deployed on multiple pods. Two to
Mm-hmm,
three pods are running. So directly API server will go and ask the nodes. It won't ask the node. It should have some data storage, right?
mm-hmm.
So in that data store, it will go and communicate that how many pods are running. So HCD will store all the related data regarding your entire cluster. Getting the point here?
Yeah.
No.
Yes.
I'm
So
not satisfied with the answer.
yeah, so the thing is like that. So
Mm-hmm.
like how many pods we have, how many nodes we have. So
Mm-hmm.
we instruct to this add code, or it will get created automatically when we create a pod or node.
We don't instruct it. Automatically API server will give the data. See,
Okay,
when the user is trying to create any service, first of all, he will communicate with the API server and he will try to install all the pods and everything on the nodes, and then API server will give that entire data to the HCD to store the values.
okay,
Yeah.
okay. So that at the end when we open this add code, we will have all the information about the clusters, right?
HCD, HCD,
Okay,
not
at
code,
CD.
HCD,
Okay, at CD. Okay,
ETCD. Mm.
okay. So at the end, sorry. So at the end, when all the cluster got created,
We
when we
don't go
open this,
and we don't go and communicate with HCD. See, we run the
we
commands
uh,
kubectl get pods. If I run
uh,
that command kubectl get pods, what happens here? The command will fire the API server, and API server will communicate with the HCD and give me the number of pods running. We are communicating with the HCD. Who is communicating with HCD?
API server.
Yeah, obviously. So if you want to know how many pods are running, directly you won't go with the HCD. Okay, so you will go with
Oh,
the API server, and API server will get fetch out whatever the required task you want. Okay,
okay. So
all this data will be available in HCD, and this will be available with the help of API server. That's it.
so we do not have any control on this at CD.
Why we need to have the control? That's my question.
Okay.
Why you want to have the control over HCD?
Mm-hmm. No, no. I was thinking something else like that. This etcd is something like the log file where which has all the information about the clusters.
No, HCD is not a log file. It will have the entire information about the cluster in the key value format. Whenever you want, it will API server will communicate with HCD and provide you the data.
Okay.
Okay.
Got
Yeah.
it. Got it.
Any another question? Fine then. That's all for today. I am terminating the session here. Tomorrow we will meet and discuss about the cops. Okay. So that's all. I am terminating the instances. Have a nice day, and we'll meet on the next session. Bye, guys.